All right, welcome everyone. It is 1 o'clock and we are going to start on time. There may be people filing in after we get started today, and that's okay. I wanted to welcome you to the Discover Energy Systems and NAZ Solar Electric webinar. We are super excited to have Discover joining us today to talk about the new AES Rackmount system. We will be recording this. It will go on our YouTube channel probably next week, but it'll be up soon. And we will be emailing that out to everyone who was registered. So we know a lot of times people register and get busy, so we do email this out afterwards. So feel free to share this with your friends as well. And we'll go ahead and get going, and I will introduce our presenters here. So if you're not familiar with NAZ Solar Electric, and you should be, we are a solar distributor, based in Flagstaff, Arizona. We've been in business since 1979. We design and provide technical support for residential and commercial customers around the US and beyond. As a reminder, again, this meeting is being recorded. We will share it after the event. If you have a question, you can drop it into the chat. We will be monitoring chat while our presenters are speaking. At the end, we will have a Q&A. You'll just raise your hand, I'll turn your mic on, and you'll be able to answer a question then. And we just want to say thank you for coming. Before we jump into the presentation by Discover, I did want to talk about who our presenters are today, and then also let Therese take a minute to say hello. A lot of you are probably our wholesale customers, but today we have Derek Pettingale from Discover Energy Systems. He is the Vice President of Products, so he's going to go through their presentation and talk all about this great new product. We also have James Hall, who is the NAZ Solar Electric Engineering and Sales Manager, and then Therese Umholtz, who is our Wholesale Manager, which hopefully all of you know. If you're not a member of our wholesale program, our partner program, she's going to talk about that here for just a second. So I am going to turn this over to Therese and let her say hello here for a second. And here's some information about our wholesale program. Therese?
Yes, hello and welcome. Thanks so much for attending. If you are new to NAZ or the partner program, we love our partners, and most of you are installers, but we also do work with just dealers and resellers as on case-by-case basis. We offer great pricing and personal service and fast shipping. We have 3 warehouses in Flagstaff. Everything ships from here except for what doesn't. But in any case, it all ships very fast, and we hope you'll reach out if you're not part of the program already, and if you are, welcome.
All right, thank you so much. So we are going to jump right into it. I'm going to turn this over to Derek. He's going to share his screen. And Derek, go ahead and take it away.
Thank you. Just hang on a sec. Here we go, team. Let's get set up and go. All right, here we go. Thanks. First of all, big thank you to NAZ for giving us the opportunity to present a new product. And we'll get into that right away. But first, a little bit about Discover Energy Solutions. We've been in the game for a long time. Our original parent company was some 50 years ago established in the lead acid business, and we moved into lithium probably about 10 years ago. And I've really been going hard in the solar business for probably the last 7 or so. What are we known for? Discover's really known for the battery you see in that room in the background there, the AES 7.4. Battery's been out for a while. That's a 3rd generation battery. Today we're going to introduce its successor, which is the 4th generation BMS product. And that's one of the technologies that we're really known for, is our high current BMS. Additionally to that, we were one of the first to get into closed loop aspect of batteries, and being able to make the battery communicate with the power inverters and charge controllers, etc., in a 2-way. We do that through our LYNK Gateway device, which will feature in today's presentation as well. Very useful device. And then really now we're getting more and more into software. Interesting to be a battery company that's into software, but that's the future. Link Access is our first real user-friendly piece of software that enables you to look at Gateway and do the configurations and such that we'll be talking about here. So the 7.4 is still a great battery. It's been around, it's robust, it's well known, it's a strong performer. Price was lowered earlier this year, so we continue the trend of lowering cost of lithium to the end user. This battery is well known and will be with us, continue to be with us for a number of years out there. It's fully certified, scalable, has communications, all the things that we've established our reputation around. It's available from NAZ today, and we love working with it. There are tens of thousands of these batteries out there installed. The other device you want to highlight is the Gateway. As I said, this is an important device that goes between our Rackmount product, which we're coming to, and the AES and any of our digital lithium batteries. Its main job is to translate one protocol to another. So to translate Discover language into the language of, say, the Schneider Zambus or Solarc's equipment, to speak to them, to Victron, to SMA, and so on. There, each one has a different, slightly different protocol. This device enables the discussion between our batteries and their products. Additionally, it has 3 relays on it, which are very useful for controlling generators, start-stop, for load dumps, and load shedding setups as well on that. We'll look at this a little bit more closely as we go through, but it's an important device that it really enables the full potential of our lithium batteries. The software, as I mentioned earlier, this is our new thing. So we've developed a new piece of software called Link Access. This is what you use to work with the Link device, see the batteries on your network, do diagnostics, monitor them, ultimately set up those relays that I mentioned on there for their functionality, and very useful piece of equipment. This is the star of today's presentation. So here we are introducing AES Rackmount. This is our newest product coming to market. We'll begin deliveries very shortly in December. We've had a large number already out in the market doing testing and evaluation, and had a very successful 6 to 8 month period with this battery in the field. To begin with, it's a 19-inch rack-mounted battery module. It's 5.1 kilowatts or 100 amp hours and nominal 48 volts on there. There's actually 2 models. One has a heating mat in it, one doesn't. Depends on your location you need for that. There's a slight price difference to that. I think the heated one costs about $50 more. But that brings me to the topic of the price. This price entering the market at an MSRP of $1,900. This is a real game changer in terms of dollar per watt cost. And the like out there, as you can see, $371 per kilowatt hour. That's really changed, quite a big difference from where we've been operating with the more traditional battery enclosure style lithium products. So entering the next generation and moving forward on the price front there. This battery can be paralleled. There's a number of products which I'll show you coming up that in the ecosystem of this that make it very installer friendly and very quick to install. This particular battery module hosts our 4th generation of high current BMS. So we'll talk about some of the details on what makes that special coming up there, and of course supports closed loop communication and interaction with the inverter chargers out there via the LYNK Gateway. It'll be fully certified UL9540 and everything else in there. We'll look at that closely upcoming in this presentation. And it has our traditional and very strong 10-year warranty and throughput performance guarantee, which I'll explain a little bit more in detail. But let's move on to look at the ecosystem that is available with this. So the installer, the ease of installation, the speed of installation has been in our mind from the very beginning as we designed this product. We've made it so that you can stack it up, take advantage of that small footprint, stack it up. We're providing quick stack racks. These are brackets which fit to the front and back of each module, and you stack them up, as you can see on the right-hand side there, very quickly, as many as you want or as few as you want on there. No real tools other than a screwdriver to mount the faceplate to the bracket there. Otherwise, everything is by hand without any new tool. The second additional device is a battery combiner. So most of the DC bus efforts and home run, battery cables, all that is taken care of by this device. It's all in one. It comes fully assembled. It fits in the rack, 19-inch rack. It fits in the same bracket as the battery modules do. It has 6 sets of battery cables, which are fused. They're all tied together with the disconnect double pole breaker on the front. So you can, using one of these combiners, combine up to 6 battery modules separately, put them all together there, and then disconnect the entire group using the breaker on the front. The communication of each battery is daisy chained together, and finally daisy chained to this model that enables a power off, power on of the entire stack as well. So this is a very useful time saving item for installers. Additionally, now not everything's going to be installed indoors, and then some people want things hidden away. So we have this 30 kilowatt slimline enclosure. So it allows or accommodates 6 of the battery modules there. For those that were at RE Plus, you saw our sample of this on the show floor. The installation procedure is again straightforward. The battery modules are inserted, as you can see on their side, and then in front of that, a bus bar system is hung. That part comes pre-assembled. That all it needs to be is hung and then onto the shelf and then bolted in. There's battery cables that attach, another 6 set of battery cables there that attach to the batteries. That's all pre-done for the installer. Then there is also a need to put punch a hole, so the battery home run is punched wherever required and attached to the bottom of the bus bar. There's a space in there for the installer to add an additional breaker or DC fuse as required or needed for the system. Going forward, this is the system that is going to be UL9540, and we're projecting a 9540 with the Solar 15K, 12K, and the XW Pro. That's what we're currently working on finalizing that certification.
Before you move on, yeah, all I have to mention here, so this is James, by the way, I'm just going to interject. I tell you what, Discover's really taken a lot of consideration in busing, right? So like one of the challenges in design that we have to deal with on a regular basis is figuring out how to deliver the power from the battery bank. So, the combiner, that has a 500 amp AC out or DC output, capacity. So if you go back to your slide 7, that's an impressive little combiner. So 6 batteries, 600 amps of potential output from these batteries. You can run that through that combiner and deliver 500 amps to your equipment, 30 kilowatt hours. And then the same with the enclosure, right? So that's an important consideration in system design. I think it's really important to note that you guys have done it well and taken that into consideration rather than just leaving it to the distributor to figure out how to bus everything together. So I appreciate that.
Okay, well, thank you, James, there for the extra push there. Yeah, just to redraw your attention. Double pole disconnect breaker, 250 amps each on that. So really supporting, intended to support dual inverter on that. Or so with those 6 batteries, of course, more can be put into parallel, and we'll talk about that briefly coming up. But yeah. So why AES Rackmount? We need to dig a little bit deeper in here. These are the basic tenets that we're working with. So we wanted to make it very simple for the installer to put together a system, eliminate a lot of choices and bomb construction for things to purchase, as James was explaining there. The combiner helps a lot on that. But basically, it's do I want to put it in a rack system? How many modules do I need and grab a combiner? You're good to go. Or do I want it in an enclosure? Again, it's really then a choice of how many units you want in an enclosure. That's it. Couldn't be simpler. We also made it quick. I've set up a number of these systems, so I can attest that putting them together is fast and quick. It saves a lot of time. The most junior member of the installation crew can put this thing together. So that's very useful. Eliminates a lot of guesswork and potential issues out of there. Of course, we continue closed loop. Everything we do is closed loop, and we're going to talk quite a bit about the benefits of that and how that's delivered. And then certification on that. We know how important safety certification. So this product is UL970 safety certified. We've just finished our 9540A, and we're just hoping that the report will be in the next couple of days. So that's been done and behind us, and now we're working on the 9540 certification with Solar and XW product to begin with. So 5 kilowatt module, 19-inch rack mount, small footprint, high energy density, heated, non-heated choice there, one or the other. The front connectors are Amphenol Sherlock connectors on there. They snap on easy, they lock in place. There's no tools required to do that. Very easy to, basically pull a module if it need be, or to assemble the whole thing. 2-pole breaker on the battery module itself, so that breaks both positive and negative on that. Another feature of safety and protection. There's an on-off key on that on the battery. A little green light comes on their status, which tells you the battery is on or off. And then our communication ports on the front of the module. Quick installation out there. There's a picture of 3-stack there. That takes about 15 minutes or 20 minutes to put together, about 30 minutes to put together a full 6 units. And most of that is just taking them out of the boxes and packaging and getting them ready on that. Screwdrivers, all it is required to lock them to the faceplates to the brackets on that. The swim line enclosure, a little bit longer, but still pretty fast on that. Main effort there is really to locate and put in the exit for the home run cable. A knockout punch is required for that procedure. Paralleling, we can parallel these things. So as you can see there in the picture, we parallel up to 30 rack mounts at this moment. We're working hard to push that harder, but as of this moment, 30 modules can be paralleled together, and that's in closed loop. Open loop, it's basically unlimited, the number that you can put in there. But from a closed loop perspective, the communications will support up to 30 in parallel. That's 5 of the stacks or 5 of the swimline enclosures in parallel. Mentioned, we focus a great deal on closed loop. You can see a detailed picture there. Each battery comes with a Cat5 to connect to the next one, so they can be all paralleled up there. This is important. Closed loop is where the state of charge and other battery data, such as voltage and temperature and stuff, originates from and is shared between the battery modules to the LYNK device and then on to the inverter chargers out there. Presently, we have closed loop integration with Solar products, with Schneider products, with Victron products, with SMA products, Studer, and also Morningstar on that. Regulatory certification, we go forward with these. We've just got our 9540A report the other day, just coming together. We're proceeding with the Solar and Schneider 9540 certification, and we'll have that done within the next month or so. Here, one of the key things about our batteries is a little bit different there. We talk about energy throughput, and we have a performance guarantee on this. It's a little different. We actually guarantee the battery works and that it will do 30 megawatts of energy throughput. How can we do this? Simply because the BMS in there, it's a digital device. It data logs all the energy in and all the energy out of the battery. We know that it's displayed. You can go see it using LYNK. You can see the total system throughput. You can see the individual battery throughputs on that. This really changes the game. The concept that we have been borrowing from lead acid about cycles really becomes obsolete. What can what is a cycle? Everybody's definition is different of cycle. What's the depth of discharge on that? Are they back to back, and so on and so forth? It was a construct that really was put in place to help people understand, how long they could use things for. Borrowed from lead. It really doesn't matter anymore in the lithium world because we're digitally tracking all the energy, and now it comes down to energy throughput. It's a much higher, much more qualitative way of measuring the usage of the product. We're also, we're just able to do. It's just better. I mean, the whole thing about cycles has become obsolete. For those that are still stuck on that, I could sort of articulate what is 30 megawatts worth. Well, 30 megawatts, if you took 5 kilowatts and you did a charge once a day and a discharge once a day, so 10 kilowatts throughput a day, you wind up that energy performance guarantee would support about 8 years of daily cycling, if that was your definition. Now, the energy performance guarantee is not the lifetime of the battery. That's just approximately 25% to 1/3 of the total lifetime of the battery, but that's the part that we stand behind, along with the workmanship warranty. Like to delve a little bit deeper, as I said at the outset of this presentation, BMS is something that we're focused on quite a bit. Now, why does it matter? We're now becoming more advanced in our understanding and the way we use lithium. So BMS is becoming important to us, and we need to begin understanding this. So first of all, this is our 4th generation. It's built upon the 3rd generation. The 3rd generation is what's in the 7.4 battery. We now moved on to this. We always focus on high current. So what does high current mean? It means the capacity, the amount of energy in terms of amps, how much can flow in and out of the battery relative to its capacity. So we're able to take basically a 1C rate there. That's the full capacity of the battery in and out in 1 hour. So what does that mean? It takes 1 hour to charge. If you have a 100 amp charger, it'll take 1 hour to put the 100 amps back in, and it also could be discharged in 100 amps in 1 hour as well. That's high rate. We have now what we call continuous rating. As we see the evolution of these ratings move forward, the way UL is starting to test and measure these things, they're looking at now continuous as a different from its a maximum charge rate and maximum discharge. So continuous is defined by the UL testing is a charge and discharge and charge followed by an immediate discharge and charge. So in other words, back to back, a 4-hour process on that within, and you have to remain within safe temperatures and other cell operation. For that, we're rated 70 amps. And then the max charge is defined through the UL testing is 95, or basically a 1C rate. We also have very high peak on that. So this is important for operation with off-grid inverters in particular. to match the surge capabilities and the surge requirements of those. You need some peak. The battery has to be able to follow the inverter, do that. So these are important aspects to be monitoring and looking at when you're selecting the battery. We're proud to say that we have some of the best specifications to this. Benefits of all of this, it decreases the charging time on especially on generator. If they're off grid using generator, you get it done in a faster period of time. It means less runtime and less fuel on that. If you're talking and using solar as a charging source, less time on solar works better in shorter days or periods of cloudy weather, etc. It just gets the job done faster on that. So high current BMS, and we'll look at that, the impact of this on costing of a system and how that affects it coming up. Some of the other things, so internal to that, some design changes that we've made in our 4th generation within the BMS. So we've moved from a MOSFET design to a dual contactor design. There's a higher reliability in dual contactors being there and less cost involved in that. So in the Gen 3, you're seeing a Gen 3 BMS on the right hand side, or certainly the power switching part of it there. You can see there's a lot of MOSFETs in there and a lot of heat sink in there to deal with the heat. And then you can see the dual contactors, which are in the Generation 4. They're responsible for the same thing on that, but just a higher reliability on that and a lower cost of design there. And primarily, we also see that those contactors are much better to handle what we call the inductive kickback, or the voltage spike that comes when you're turning on things, non-linear loads, motors, and that type of thing. We also see kickback coming from inductive kickback coming from long DC run cables and things like that. So that's why we're always recommending shorter battery cables and the like. So this is a big step forward in terms of BMS hardware. The BMS firmware matters a lot too. Some of you probably heard me talk about dynamic charging being important, and what is that, and what are we providing here? Well, with closed loop, of course, we're communicating our battery SOC, our voltage, our temperature, any faults and all that type of thing in real time with the inverter. We also are sophisticated enough to continuously calculate and optimize that. So one of the things that we're looking at is specifically what voltage is being delivered at the battery cell level. We're translating that into requests back to the inverter. We aren't just sending a charge target, a static charge target, and saying we're done with that, charge us at this. We actually move that number around. And in this way, we're able to compensate for impedance and resistance between the charging device and the actual battery cells themselves. So all those connections in between there. Many inverters out there aren't particularly good at regulating voltage at the terminals. This overcomes those types of situations there. And in the end, we actually begin to achieve the full, high-speed charging capability of lithium. So you can see there in that chart, there's a particular example there where I've, done some testing, and we've had a system, an identical system. On one side, we've done a closed loop with full communication, and then when the other side, we've, removed the communication and just charged it open loop. So, same lithium battery, same depth of discharge, same hardware doing the charging on there. And you can see we go from 113 minutes to 64 minutes to do the same job. Huge savings in time. That's going to help with those generators and solar, short solar days, etc. There's quite a big difference on that, and that's what dynamic charging gets you, that particular aspect. And that's firmware, essentially a firmware driven thing. It's not necessarily available with others unless they've gone to the lengths of that we have to develop the firmware. I'll now highlight another aspect of it there, and I've kind of zoomed in on a piece of that graph from the previous page where you see voltage jumping up and down there at the top end of it, top end of the charge. This is what we refer to as dynamic balancing. And in here, we're actually at the final stages of charging. The cells themselves are now starting to look at each other and starting to balance out charge there. And you can see what we're doing there is moving the voltage up and down. And we're simply protecting and operating around the protections there to keep the batteries from over voltage on there. And this is what you'll see in a lot of other BMS control mechanisms is their inability to pull voltage up and down dynamically they're just focused on a static voltage, and they'll simply go over voltage and they'll cut off the balancing process. So you won't get full balancing, you only get a partial balance or perhaps out of that. Why does this matter? Well, this is where the longer battery life comes out of it. Really, we're actually just attaining the potential of it, and others are getting short on that. So it's not like we're making them any longer life than their promise. We're just reaching that promise of lifetime that we've been claiming, and we're doing it more often with a dynamic balancing approach. Another aspect of our BMS, it's serviceable. It can be changed. It can be swapped out if there's a problem in the field. Not all batteries, many of them you can't even open or access them, but ours do come apart on that and can be serviced in the field. This accelerates the ability to deliver, and deliver parts, etc. It's easy to FedEx or DHL BMS, etc., than it is to move an entire lithium battery, which is a dangerous good and requires special transportation on there. So it's serviceable on that. Again, I also point out that we can diagnose problems using link access. We can see each and every battery in there. In fact, if you're in touch with us around a suspected problem, that's almost assured that we're going to ask, our tech support is going to ask for the data log out of this and go through it quickly to ascertain the condition of cells out there. Most times we eliminate cells as a particular problem, then we can focus in on BMS and setup and operation of the system in the field on that. So now let's look at this challenge that we have of selling a system. So to help you, we've got some videos out there on the left. I'm not going to show you this. Is a video that introduces the product. We're there, so quick couple minutes of features if you'd like to review what I've been presenting. That's a good one to have a look at. It's on a website. We got a couple or more than a few data cell sheets. These are all available from the website, and you can see in more detail what the offer is and some of the specifications. Now, how do we compare against the competition? Well, the first thing I want to kind of knock back is don't get caught up with the telecom type of rack mount. Rack mount telecom batteries have been around for a while. They're pretty inexpensive. There are reasons for that. Typically, they have 15 cells in series producing 48 volts rather than the 16 in series or 51.2 volts that we and others produce on that. That's going to make a difference operating with your inverter. The inverter's going to fall down when on those telecom batteries. The 48 volts is just not strong enough to support things that's going to cut out much earlier. The BMS in those units is most typically a low current. There isn't the need for quick charge and discharge on those, or even, and there's no need for peak in a telecom application. So typically, you will see a charge discharge rating of as low as 0.2 C, which would be 5 times slower than our battery at being recharged. So, that's 5 hours versus 1 hour. The peak, there isn't any in those batteries. They're not required in a telecom application to do that. Often they only support an RS-232 communication, not the CAN bus, the high-speed CAN bus that we do, nor do they have the firmware on that. Another typical telltale sign is that they have dual DC inputs to the battery. So these batteries are intended to be series connected to, or pardon me, parallel connected to each other to extend their capacity, rather than where our type of system where we're going to a bus bar. This affects the amount of current that can go through the system. The telecom with the battery to battery power, the current of the entire system is going to be limited by the current can fit through one of those parallel connections. Unlike the system that we have chosen, where the current is limited by the DC bus, and each battery has an independent pathway on that. So stay away from those. No matter how inexpensive those particular kind of batteries, they're not going to support inverter use. Here we look at some more of the more relevant competition out there. So these guys are well known. They're the Simplify, Fortress, Pites. I've selected a different range on there, put up the different specifications there in terms of their BMS performance. And so I did some survey a few weekends ago of online pricing. So click to buy. These are what they're offering, and you can see the dollar per kilowatts there. I'd like to now take you through a sizing of a system and show how these parameters of BMS affect the actual cost of the system and the limitations that are imposed on systems by that, and get into more detail. So, how does the BMS affect system pricing? Let's go through this. It's important. Whoops. Beg your pardon. So, when sizing a battery system, we all know required runtime. It was the same in lead acid. How I want loads to run for how long? Typical question, essential question on that. So that is one thing. But now, because every lithium battery has a BMS in it, and that imposes some restrictions and limitations on current carrying capabilities, we now have to look at the ability of the product to support the charge current and also the discharge current. And there are differences there on both the batteries and the inverters out there. And then peak current, so the ability of the battery to momentarily, give more energy out there and support the inverter's surge. So there's some formulas on there. You can have a look at it at a later time as we and sort of adopt those in your sizing. But I'm going to refer to an example here. So I've chosen the Solar 15K, a big beast of a product, 12,000 watts, continuous, 24 VA surge, huge battery charger and capabilities there. So let's have a look at how we would support and others would support this product and what happens to pricing and system cost. So to get the minimum, required batteries to support a load, I've just arbitrarily chosen a 6,000 watt load. We needed to run for 3 hours. To convert that into consumed DC watts, we also need to divide by the efficiency of the inverter. So we get a total of almost 19,000 watt hours out of the thing to support that. Taking the stats from the BMS and stats from before and looking at how each one of the battery systems would support that, we can see that taking the watt hours divided by the capacity of the battery, we get a number of minimum batteries there that would be required to support that. Pretty straightforward. One would start to think, hey, this is the answer. Certainly, this is what dollar per watt is all about, and we can see true to form, dollar per watt is the guiding principle on this. But what you also start to see there is the actual cost of a particular battery starts to change the things there. Now, 4 batteries, they got a different price from different manufacturers on there. Starts to weigh in. A $12,500 system is a lot more than a $7,000 system. So this is starting to play and factor into it. However, I want to go through the other aspects of charge and discharge and peak. One would think that, dollar per watt, that's the be all end all to the story. It is not when it comes to lithium batteries. So let's look at that and the effect on the system cost. So taking our Solar 15K as a peak output of 24,000 VA, 97.5% efficiency, 48 volts is typical cutout on that. So we look at that as the edge case to support that particular surge, and we would come to about a 512 amp DC draw and the need to support that. Looking at our batteries and their BMS capabilities to support a peak output, I've divided that 512 by the peak output of each one of the batteries out there, and you can start to see the number of batteries are changing, and consequently this has an effect on system cost. So this ability of the BMS to go peak, and you want peak to happen like that happens where you're starting up a load. That's where air conditioning and being supported, where pumps, etc. These are where the calls come from. Owners of the systems is why is my system shut down under these circumstances? Why is it turning off when apparently randomly sometimes? This is often the case there. So peak is very important sizing, and you can see how this starts to affect the minimum system size out there based on the capabilities of the BMS in the product. Now let's look at charge and discharge sizing. Where fortunately with the Solar product, it happens to be charge and discharge are the same number, 275. That's relatively normal for product. It's bidirectional, so what you take out of a battery is what you can put in to the battery through charging, often the same. I caution you, it is not always the same, so check the data sheet of the inverter involved. Anyways, to simplify here,
hey Derek, can I add something here? So it's important to note that there's a difference between surge and charge and discharge. Surge is an abrupt situation, whereas charge and discharge is considered a continuous rate. I think that's an important distinction to make.
Fair enough. So charge and discharge continuous. Peak is that temporary, short duration thing here. So, anyways, returning to the example, Solar makes it simple for us because according to their spec sheet, the charger is 200 amps, 275 amps, and so is the DC maximum DC input required to deliver continuous output of the inverter. So again, this is often actually where the separation of BMSs occurs most dramatically. That continuous rating and that max charge rating of the particular battery, this is where the money is in a BMS. This is where contactors versus MOSFETs come to play, and frankly, to deliver, you have to put more metal inside it to carry the current. That all costs money, and people, designers like to avoid costs in their products. So we'll see quite a bit of difference here. We can see that the simplified battery has a very low continuous rating, therefore requiring more batteries on that. Fortress, not so bad. Pites, again, they have a low current BMS in there, so kind of a number of more batteries required to support that. I think the theme here. It's going to drive system cost upwards in all cases there. So this is important, sort of to summarize in the end here, presentation, really the BMS has a big say on what the system size and therefore the system cost of the lithium batteries can be. I'm proud to say that rack mode has a very strong BMS in it. It's able to support these configurations there that was spoke to for less money than the other guys. So, I put that forward as a good reason to buy our product, along with the other things that I've discussed previously there. So we're kind of at the end of presentation, and catch up now on some questions, etc. there. I've been talking, so I haven't been monitoring questions. Let me do a bit of a
it's
screen.
my turn to talk here, Derek.
Yeah,
I got to take
okay.
over the conversation. Then we can go to questions, but I got to provide my perspective.
Yes,
So,
please, James.
all right. Let me share. You're going to have to stop sharing, Derek.
Oh, okay. Sorry, let me. You can have it back.
All right. Hi, I'm James. Introduced earlier, interjected on Derek's conversations several times here. I want to provide our perspective on this battery. And I mean, the takeaways from, the current, just currently what was discussed from our perspective. So the first thing here is I have to say that my marketing team is constantly reminding me. Can you see my screen? We're good?
You need that. Yeah.
All right. So constantly reminding me that I need to consider all perspectives. Okay. And so the first thing we need to talk about, because Derek covered the comparisons between multiple batteries, is really whether or not it even makes sense to consider lithium or lead in the first place. And I think we're at a turning point here in the industry. Okay. Especially with this type of solution and the various other solutions that are coming about. It just really doesn't make sense to even think about lead acid anymore. Okay. So with that being said, I mean, I have broken up some comparisons, and the reason this even came up is one of my colleagues was talking to me yesterday before I left, saying that, he had a customer who was buying 24, lead acid batteries, these S6 L16 Rolls-Royce. I mean, look, Rolls is a reputable battery manufacturer. They made a really good battery for a long time. He was looking at the system that was, this was going into, and, basically posed a question as to like, why are you, considering these batteries, right? I mean, we have, he was trying to do a 30 kilowatt hour battery, 24 batteries. The total cost there is basically $9,500. Okay. Well, to use a similar rack mount solution, you're at like maybe 15% more cost to go with lithium. You have no maintenance. It's a system that you literally can install and pretty much forget about for the next 10 years plus. Okay. But, you were comparing that to flooded lead acid. 15% cost difference is really insignificant in the scheme of things. And I think that's important to consider. But what's even more interesting here is that lithium has gotten cheaper than AGM. All right. Like the North Star battery is a pretty reputable AGM battery. It's not cheap, but it's really good quality, can deliver, it has its applications, but it's about 6% cheaper to go with lithium than it is to even go with AGM. Not even considering, it's a quarter of the weight, a quarter of the size to deal with. It's much more sophisticated. It can be monitored. It's safer. Look, the rationale here is, really it doesn't even make sense to pose this question, but the question does get posed, and I wanted to address it. All right, so what I want to talk about now is why we are excited about this battery, specifically this battery. All right, and to be honest, almost all of our designs, our engineered solutions these days they're very biased towards closed loop communications. Okay, if the system really isn't doing closed loop, we really question, whether or not the equipment is suitable. All right, so if you want to get a system designed by us, have our backing, our support behind it, we're going to expect that system to most likely be closed loop. Why? Because we can support that. much better. It's safer. It's easy to configure. It is just the best way to go. And there's plenty of high quality equipment on the market that supports closed loop communications, with this technology. If you're not doing closed loop communications with your lithium battery solution, you're really missing out on one of the most important and safest aspects of lithium battery technology. And honestly, Discover does it best. Okay. I can say that because I have these batteries on my system, and I know for a fact that because I've played around with all sorts of different closed loop communications and all sorts of different batteries, Discover does it best. And it's the way they do it, pushing the voltage from the inside of the battery out to the inverter, dynamically adjusting the charging values. It doesn't get any better than that. So this is one of the most pivotal aspects of using Discover solutions with Solarc and Victron and Schneider and Morningstar, right? These common products that we use on a regular basis, we want it to be used with Discover because it works the best. Okay. Now, from a perspective of just the battery itself, the performance output makes designing these systems so much easier. Okay. You're not focused in Derek did a great job explaining this just a minute ago. So you'll kind of understand what I mean by this, but we can just focus on energy. I don't have to focus on the limitations of the BMS, charging values, inverter compatibility with respect to the output. The battery's protected. It's got fusing or breakers essentially. The closed loop can limit the discharge potential of the inverter, and it can do this on a lot of other products as well. But you can get a lot more. I mean, one of these rack mount batteries can deliver 10 kilowatts of power output, or slightly more than that, obviously. But just to keep the math simple, it's 10 kilowatts of power output on one battery. It takes the worry out of this inverter going with this battery. It takes that out, and we can just focus on the energy side of things and just make the system come together and focus less on the inverter scale, meaning we can just throw a big inverter at a small battery bank because we need that inverter to handle the surging and stuff, and the batteries will just deliver that power. And we can just focus on expanding the battery bank after, as the energy needs become more obvious. Okay. With that being said, scalability, right? So 5 kilowatt hours all the way up to 150 kilowatt hours, and they're working on more. Look, here's the deal. If you're doing a project where you need more than 150 kilowatt hours of storage, really need to be talking. It's maybe not ideal. You're in the CNI side of things at that point. If you're getting up, above 150 kilowatt hours, we really need to be talking about the project in a little more detail. But options are good, and a dynamic system design is really important for us, right? We want to be able to say, okay, here, you go with 6 batteries, and if you want to call me back in, a few weeks to get 2 more batteries because you just realized you needed, 40 kilowatt hours instead of 30 kilowatt hours, no big deal. We're not put into a corner on the energy storage, and we can really move up as needed. All right. So the scalability is very important to us. But look, we field so many questions on a regular basis about low temperature. All right. Amazing that, Discover really thought about this. The heating side of things is really important. I predict that a significant amount of our batteries that we sell are going to be the heated option. I've already moved a bunch of these products out into the market for some special projects, and they're all considering the heated option. It's a pivotal conversation with us. And so being able to have an option that can deal with these low temperatures, can deal with outdoor installations, has a nice enclosure that it can all go with, and deal with the temperatures is super important, right? There's all sorts of solutions where you can add external temperature controls and stuff like that to make the solution work. But this isn't a band-aid. This is a solution that's incorporated, and we think here that's a really important consideration. So take that away. But it's not the most pivotal consideration, right? Listings are super important, and having a solution that's manufactured by a reputable manufacturer, that's supported by a reputable distributor. Like, we've been doing this for a long time. We vet every product that we offer and they have to meet certain standards. We have to be able to use them nationwide. We don't make exceptions for, you know, it being off grid or it being grid tied. It has to be a good quality product, top to bottom, without question. And to be honest with you, the delays right now with, like, we were expecting to see these batteries in October. Derek's not going to want me to tell you this because, you know, we were all super excited about it. That's why some of them, you know, got moved out. Look, they're taking the time to make sure that this listing is 100% done before they start moving their products, and that's caused them delays. And, you know, it is a thing that we have to deal with, but it's super important for us to consider the listing aspect. And there's too much product out there that doesn't have these listings, that doesn't have, you know, these safety considerations, and they're just pushed out into the market. It's caused a lot of problems. It's caused, you know, house fires. It's caused all sorts of these issues. And having a product that's been listed by a reputable NRTL, nationally recognized testing laboratory, you know, to the applicable standards that are going to be required in the NEC 706 article, like, these things are super important, and we have to design systems around, you know, the National Electric Code and what's required, regardless of whether you're off grid and you're not permitting it, or whether you're grid interactive and you require it permitted, or it's going into California, or it's going to New York, or it's going anywhere else in this country or this world. We still are going to consider the most important aspects, and that is the safety standards, you know, need to be addressed. All right. So here's the thing: is, like, price really does matter at this in this industry. Well, this day and age, there's a massive price war in the lithium battery side of things. To be honest, I don't want to be the race to the bottom, because this is that kind of that concept that you deal with, that good, fast, cheap little thing that contractors talk about. Like, you can have it good and fast, but it's not going to be cheap. You know, you can have it fast and cheap, but it's not going to be good. You know, that concept. You really need to consider the product and what you're getting when you consider the price. Like, 1900 for, you know, 5 kilowatt hour battery, it's not expensive. It's not the cheapest. I think it's good balance, but the advantages you get from this product far exceed that of other products on the market. So bear that in mind, and then understand that you have us behind you as well. Like, we come with some reputation, and we have to uphold a standard that we've kind of portrayed here. And we don't just offer anything because it's the cheapest solution. It needs to meet all of our standards and requirements before we will even say, hey, this is what we want to do. This is what we recommend, so on and so forth. And again, we want it to be easy to design with, easy to support, worry-free. We want it to have closed loop. We want it to be scalable. You know, it has to be safe. And it's really important that, you know, it's easy to use in a variety of different environments. And so this product kind of meets every single one of those all in one shot, with, you know, a reputable manufacturer that's been around for a long time, and a reputable distributor like us, where we're designing systems. We're literally the experts in solar and ESS. You're not going to find that from anybody else. We can design the system for you. You know, we're a partner to you. We're going to design the system, we're going to distribute it, and we're going to support you from start to finish, right? On top of that, you know, we come with this relationship with Discover, okay? So we've had a relationship with Discover. They were one of the first lithium batteries that we even ever offered, all right? So for them to be relevant in the industry and still coming back with new products as this industry is growing and changing and dynamically adjusting, it's a good relationship to pull back on. And I think it's really important to understand that, you know, Discover and NAZ, we are a partnership, and NAZ and you as the installer or the DIY customer, we are a partnership. So this is a full circle situation that's important to address. So with that being said, we can go ahead and move on to questions.
Yeah, and I would just like to reiterate that too. Sometimes in the past, some of our installers may have been reticent to ask for, you know, design or product or technical assistance, but we are all there for you, or our entire team is there for you. So don't don't ever hesitate to ask for that. And if there's anything that we don't know, we'll go straight to Discover and get the answers as well.
Thank you, guys.
Yeah.
Thank you. Sorry, go ahead, Matthew. Or whoever was getting ready to talk.
Is Derek? Yeah, there was a question regarding the combiner. Is that necessary? No, technically it is not necessary to put together a system. It's just super convenient. Everything's done for you there. If you elect to go without it, you will need to get some Sherlock connectors to be able to connect your batteries to the charging system or DC bus you're putting there. Those Sherlock connectors are widely available. We offer them as well. I'm sure NAZ will make them available to you. They just need to be crimped on to battery cables, and then you can connect to the battery faceplate. Of course, with the combiner itself, as I mentioned, it has 6 cable sets already pre-installed in that, with the Sherlock connectors on the other end on there. So
and fused too.
Yeah, and fused. Each line is fused inside the combiner box. If you don't want to, or you don't need 6 batteries to the combiner, you simply depopulate that. The top comes off of that combiner box, and a couple bolts undo the nuts on that, and you take the cables out, and you have 5 cables or 4 cable sets or whatever
we have all sorts of busing too if needed. Like, the combiner's a convenience. It allows you high current distribution that is protected, right? So that's an important consideration. But if you're only doing 3 batteries and you only need support 300 amps of current, we have plenty of different busing options to support these types of applications. In fact, we just did an RV with 3 of these batteries, and we just used Victron LYNK's power in. Okay, so you don't need to use the combiner, but certainly it makes for a convenient solution on several installations where you're dealing with high current and the output from one single source. And the combiner also doesn't have to go in the middle either. It can go on the top. You can potentially put it on the bottom, although I don't think that's important, but it can just go anywhere in the stack.
Yeah. There's a picture of the connectors that we offer there. They're UL rated. We actually changed them in the development process to get those there, so they'd be UL safety rated. The barrel comes off, and you slip the cable in there, crimp it down, slide the barrel back up the wire, and tighten it up, and that's the procedure. It's pretty simple to crimp them on to cable.
I would like to remind everyone that if you have questions, if you raise your hand, we'll turn your mic on, and you can just chat with the guys if you have further questions.
Let's see here.
There is a question in the question and answer, by the way.
Oh, is there?
Did anyone see that?
Oh,
there's 2
sorry.
Actually.
Please confirm closed loop communication. Yes, you can use it with SMA Sunny Islands. It's not that fun to work with, but Sunny Islands aren't fun to work with, but they can certainly be closed loop with Discover. You've been able to close loop with Discover's link for a long time with SMA.
Yeah, we do that. We're not listed on SMA's, approved battery. That's a whole another effort required. But yeah, we've done hundreds of Sunny Island systems in closed loop.
Frank, the question about the price, that was all MSRP. So that's just full retail prices that were quoted. If you are a partner with us, then you can certainly request pricing from Therese, and she will get you the pricing. Otherwise, you can view these products directly on our website right now. Let me show you that really quick here. Give me a second. I'll show you where to find them. Let's share. All right, so this is our website, solarelectric.com. And if we're looking for the AES rack mount, we got all the products on the website now. Here's the deal. These are going to be available in December. So these are MSRP. If you want, you can go ahead and sign up for a notification for when these are actually available. As soon as we're comfortable with taking pre-orders, we'll go ahead and make ordering available for these. We've done a few projects with them already. All of the products should be relevant here. Oops. So the enclosures and the link should all be here. So, and then we have the cables. If you're trying to incorporate this on your own bus bars, the Surlock connections, the enclosure, the racking, the DIN racking, and the combiner is all here for the AES rack mount. So this is all retail pricing here, as you can see. And again, if you're a partner with us, if you're not a partner, then if you qualify, you can go sign up for the partner program here, and then Teresa will handle you from there. But otherwise, you can see the full retail pricing. If you have any questions about these products and how they should be used and what you're using with, don't hesitate to give our team a call. They're all very familiar with these products and super excited to talk to you about them.
Frank, I know you had your hand up a minute ago. If you still have a question, your mic is enabled. All right, anybody else have a question? Just raise your hand. As I raise my hand, I do not have a question. Looks like there's still a little bit going on in chat.
Yeah, chatting away. I will also let the audience know that the manuals, which I think Discover, and I proudly say Discover is among the best documented products out there, they're available on our website, discoverlithium.com, under a resource section. There's even a manual just for those Surlock connectors on that. So all of that is mapped out in detail for you there. So encourage you to come.
We also have all the product documents on the products of our website as well. So we try to add everything here for them too. So you don't have to jump around. If you're just on our website looking at the product here, you can see, just go down to product documents and you can look at all the relevant product documents right there for the products. But we'll have to make sure we add the manual for the Surlock connection as well. Oh, Discover Lithium's website, right? Discover
lithium.com.
Lithium.com. Go to their AES Rackmount product. And I spent a lot of time on this over the last couple of days. So here's their product on their website, and there's all sorts of resources available here as well.
Yeah. Thanks for that. Under support, you get into a place called resources.
Resources.
Under support there. Here you go. Now you can filter and you can see to your heart's content all the stuff that we offer.
Firmware,
you name it.
Certification documents, manuals, cell sheets, technical documents, everything available for you.
All right, guys. Well, we're just slightly over our hour. I just want to thank everyone again for coming. Thank you again so much to Discover for taking the time to sit with our customers today and go through all of this wonderful information. We'll leave chat open just for a few more minutes. We'll sit inside. Again, I'll email this out to everyone who registered, and it will go up on our YouTube channel. So thanks again, guys.
Thank you, everyone. Thanks, NAZ. Love you guys.
Yeah, thank you, Dirk. Hey, if you guys have any questions, don't hesitate to shoot me an email. Just james@solar-electric.com. I'm happy to address any further questions, and we can take these conversations further until these products are readily available, and then we can just use them for everything. I think it's great.
All right. Thanks, everyone. I'll get this out. Have a great day.